Good morning once again. Welcome to my channel. The last time we looked at how to determine the ground state term for a D7 atomic orbital. Today I want us to look at how to determine the ground state term for a D8 atomic orbital. First of all, we need to write down the angular orbital quantum number. For D orbital, the angular orbital quantum number represented by L is equal to 2. Then we write down the magnetic quantum number, which is represented by ML. The magnetic quantum number begins from negative L, 0, plus L, or plus L, 0, and negative L. Since the L is 2, we begin from plus 2, plus 1, 0, negative 1, negative 2. Then the spin quantum number. Each electron can spin either upwards, represented by plus half, or downwards, represented by negative half. After that, we write down the orbital. We know the d orbital is a degenerate orbital, 5 degenerate orbital. Then we write down the magnetic quantum number of each orbital. Then we fill the orbitals with electrons according to the rules in filling orbitals with electrons. So we fill them with single electron in the same spin. We have 3 electrons remaining, so we pair up, but in opposite spin. Then we determine the total orbital angular momentum, which is represented by ML. The total orbital angular momentum is determined by summing up the magnetic quantum number of the electrons in each orbital. So considering the first orbital, we have the orbital containing 2 electrons. So because of that, considering the magnetic quantum number, which is plus 2, taking into account the 2 electrons, we have plus 4 for that. Here we have plus 1 to be the magnetic quantum number, but we have 2 electrons in the orbital. So taking into account the electrons, we have plus 2. Here we have 0. Here we have only 1 electron, so negative 1. Only 1, negative 2. We have 6, minus 1, we have 5. Minus 2, we have 3. Then we determine the total spin quantum number. This is the total angular orbital momentum. This is the total spin angular momentum. To determine the total spin angular momentum, we sum up the spin quantum number of each electron in the orbital. When the electron is spinning upwards, the spin quantum number is plus half. When it is spinning downwards, the spin quantum number is negative half. So plus half, negative half, they will cancel each other. The answer is 0. So we ignore this. We do the same thing here, plus half, negative half, 0. The same thing here. So we just consider these two. Considering these two, they are all spinning upwards. So they all have a spin quantum number of plus half, plus half. So the total spin angular momentum is 1. Then the next thing is to determine the spin multiplicity by using 2s plus 1, where the s is the same as the total spin angular momentum, which is 1. So 1 plus 1, we have 2 plus 1, we have 3. Therefore, when we have the total orbital angular momentum to be 3 from the previous video, we know that if it is 0, it is S, if it is 1, it is P, if it is 2, it is D, if it is 3, it is F. So it is F. And the spin multiplicity is also 3. Therefore, the ground state term for D8 atomic orbital is 3F. Thank you very much. Please subscribe to this channel, share the video, and then like, so that it will motivate me to produce more videos like this. Thank you.